very carefully. I think the biggest problem arise adalah fasa dia berbeza. We have the presence of your liquid and we have the presence of your gas. And the pressure of the gas is given as a vapor pressure. Kenapa saya tahu vapor pressure of the water adalah sebenarnya partial pressure of water in gas equals to 23.8 torr. Okay, yang ni. Yang ni yang diberi. So kalau soalan minta KP and you calculate the KP first, it shouldn't be a problem because your KP equals to the partial pressure of H2O gas. That's it. Betul. Soalan senangnya kan? So, dia akan jadi terus 23.8 torr. If you write me this, I accept as a KP. Kalau KP kamu tulis 23.8, saya terima. Tapi kalau kamu guna 23.8 torr dan kamu kira KC dengan value ni, saya tak terima. Okay? So, you should change your 23.8 torr equals to how many ATM. So, you need to change that. We know that 1 torr equals, 1 ATM equals to 760. Betul? So, over here you should have 0.0313 ATM. Betul? So, KP value dua-dua saya terima sebagai jawapan. Untuk KP saya terima dua-dua. Tak ada masalah. Tak ada unit lah. KP tak ada unit. In our syllabus, KP tak ada unit. Okay. Untuk KP, dua-dua jawapan ni saya terima. Tapi untuk KC, kita hanya boleh pilih yang ATM sahaja. So, you have your formula KP equals to KC RT delta N. By the way, delta N equals to how much over here, Azri? Masuk lambat tadi.
Equals to 1.
Equals to 1. Alright. 298.15 Kelvin. Delta N over here adalah equals to 1 because you have your gas on this side adalah 1. Liquid on this side kita tak ambil kira. Alright. So kat sini adalah kosong. So your delta N over here is equals to 1 because it's a 1 minus 0. Delta N equals to 1 minus 0 due to the presence of liquid. Agree? Okay. So, when you do the calculation, kira lah sendiri. Okay, macam biasa, kira lah sendiri. Just what I want to remind you over here is when you're using this formula, the pressure of the KP that you put in must be in ATM. Okay, saya terlepas soalan ni semalam. Okay, boleh. Siapa yang dah buat, kira balik. Siapa yang perasan tu betul, well done. Siapa yang salah, just kira balik. Tak ada apa. This will be the type of your objective question. Nampak senang, but you use a lot of theory. Okay, soalan-soalan benda yang kecil-kecil dia suka perangkap kamu. This will be the type of question that you will come across. Okay, nampak macam simple je. Simple je pun, tak susah pun. But there will be a little bit of trick lah. From the physical phase at the beginning, from the KP and case, from the KP value itself. Okay, so be very careful on this. Okay, soalan 13 tak ada apa. We stop at question 13, I think yesterday. Then it start. Betul. Okay. Question 13 problem. Sebab tak ada equation, salah saya. Saya tertinggal kod paste equation tu. Okay. Onwards, 13 onwards, 14 until 20.
14 means?
14. 14, 19. Okay, we'll do 14 first. 14, siapa yang buka mic, siapa menang lah. Macam biasa kelas saya. Okay. So, we have a 14 over here. Take a quick look. Apa benda dia? 25 degrees Celsius. So temperature is 25 degrees Celsius. 0.056 mole of oxygen and 0.02 mole of N2O were placed in a 2-liter vessel and allowed to react to form NO2. Yang ni bukan saya tertinggal lah. Yang ni memang soalan tak bagi equation. Okay, yang ni memang soalan tak bagi equation sebab dia memang cakap allowed to react to form what? So first and foremost, when you read the question very carefully, the first sentence, the number of mole given over here is the number of mole initial, change, or equilibrium.
Initial.
Thank you, Haris. Initial. So the number of mole given over here is number of mole initial untuk oxygen gas, 0.056 mole. And then you have number of mole initial of N2O given 0.02 mole. Placed in a volume. Volume kat sini is a 2-liter vessel. 2-liter container, temperature 25 degrees Celsius. allowed to react and form NO2. When the system reached equilibrium, the number of mole of NO2 found was to be 0.02 mole. So kamu ada number of mole sekali lagi, tapi kali ni number of mole yang ada adalah number of mole equilibrium. If you read the question very, very carefully, you realize that that is your equilibrium. When the system reached equilibrium, the number of mole NO2 was found to be 0.02. So look at the way that I write my value and the way that you write your value. Make sure you label them very, very correctly. Make sure you know what you are labeling. Okay? Next question or the first question. Soalan pertama terus kepada what were the equilibrium molar concentration of O2 and N2O. Okay, dia tanya molar concentration for the oxygen and for the N2O. So over here, they're not equilibrium. They're not equilibrium, but I only have initial. The question asking for equilibrium, we started off with initial. I stable or no?
I stable.
I stable.
Thank you. And the first thing before the I stable is your balanced chemical equation with physical phase. Okay? Dalam subjective equation tu dah dapat 2 markah dah. Bye-bye. So not sangat kan objective? I don't know how to express that, how much I hate it to you. I don't know whether you feel that my sarcasm or not throughout these 2 weeks. I hate it, literally. Hate it. Alright? Bukan dislike. I hate it. Alright? I hope you can differentiate that. So much. Gone case, man. Gone case. You will be fine because you're so good. You're so good because I am so good. Right? First and foremost, balance. Okay? And if you look at it, semua yang saya letak kat situ adalah gas. Okay? We put into that is all gas. You should know oxygen is a gas. You should know your nitrogen dioxide and your N2O also is a gas. All of them is a gas over here. Okay? So when it's a gas, the first thing we need to write is the reaction. Make sure siapa reactant, siapa product, semua betul. The next thing, balance. Is this thing balanced? No. How many mole of oxygen do I need to make it balanced?
3.
3. All right. N2O?
2.
2. NO2?
4.
4. Thank you. Okay. But Tati, make sure your equation is balanced over here. And anything before the I stable, on top of the I stable, balance equation with the correct physical phase. Wajib. Okay. Selesai. Next thing about I stable is you need to determine your I stable right now. Want to be in number of mole or want to be in concentration? You choose. Kamu buat dalam apa? Number of mole or
Concentration.
Kamu buat dalam concentration. Kalau kamu buat dalam concentration, can I use the 0.056 straight away? No. Alright. Siapa yang guna number of mole as your I stable, you can put in the value straight away. Okay. But if you are using concentration, if you decided to have your I stable in concentration, then you need to change the initial number of mole to concentration first. So over here, the number of mole initial of O2 will change into O2 initial concentration. Sama, volume, saya tak tahu apa kali kita dah ulang kira benda ni sayang. Volume is a 2 liter, so you divide by 2. And why is 2 liter again? Yesterday also 2 liter kan? Nampak tak pemalas saya buat soalan? Sorry guys, 0.02528, right? Okay, mole per liter. And then you have your N2O over here in initial, 0.02 over 2. Yang ni lagi senang, 0.01 mole per liter concentration. Agree? Macam biasa, if I'm wrong, let me know. So the initial over here given, calculated, not given, because kita yang kira. N2O, 0.01, O2, 0.028, NO2. Okay, jadi berapa?
0.
Aina kata 0. Aina kenapa?
Sebab product at initial equal to 0.
Product at initial equals to 0 sebab tak ada product lagi.
Sebab
reaction tak mula lagi. Yes, kind of. Okay. Aina juga sebab semalam tak ada kan? Sayang ada. Soalan satu lah. Yang lepas ni orang lain pula jawab. Change. Can I have the change throughout this ice table?
O2 negative 3x, N2O negative 2x, and O2 positive 4x.
Kelas 7? Okay. Kalau biasa kan, kalau dalam subjektif kan, yang ni pun 1 markah dah. Alright. I don't know where, I don't know. I'm worried. Are you worried? I'm very worried. I don't know how to make you better. I mean, I can make you better. I don't know how to make you have 0 mistake. No tolerance on mistake. I can make you better. I can certainly make you better. I believe I have made you better anyway. But how can I make you have no mistake, man? Can you reset your brain and become a computer or whatsoever? Oh, well, yeah. So, agree on my ice table? How can I find my x? What should I do to find my x? Which part of the ice table are we using to find the x?
4x equals to 0.02.
4x equals to 0.02.
Product.
Okay, somebody say product. Novesh say 4x equals to 0.02, Novesh.
No. That is mole. We need to change into 0.01 m.
Okay, so I love the word product just now, whoever that opened up the mic. We will use product to find the x. But the problem arises again sebab kita cari ice table dalam concentration. So everything that you have need to change to concentration. Again, concentration of NO2 yang saya ada in equilibrium label will be equals to your 0.02 mole divided by 2 liter, forming your 0.01 m, like Noah said. Okay, agree on that? Saya nak tanya satu benda, tak apa, kita tanya nanti lepas saya stop recording. Apa benda Mr. nak gosip tu? Okay, keep it until the end of the class. We have 0.01 over here, and as we all agree, 0.01 is actually the concentration equilibrium of your NO2. That is my 0.01. Therefore, you will have 4x equals to 0.01, causing your x to be 2.5 times 10 to the power of negative 3. Setuju kah? Yeah. Okay. Perfect. Getting your x, and the question is actually asking for the equilibrium of your molar concentration of O2 and N2O. So we are actually looking for this thing. Dan seperti yang saya ajar sebelum ni, saya selalu pesan kat budak, no matter objective, subjective or whatsoever diff that you are going to have, leave your ice table bawah tu kosong. Keep some space for your ice table so that you can calculate straight away in your ice table. Tak payah tulis juta-juta kali dah. Kamu kira terus dalam ni. Alright, kamu substitute terus dalam ni, tak payah nak tulis balik concentration, siapa equilibrium, semua tak payah. So you will calculate straight away in here. You substitute your x into here, you press your calculator straight away, you will then get the concentration at equilibrium for your oxygen, for your N2O. Easy. Okay, dalam subjektif lagilah saya paksa kamu buat macam ni. Buat apa nak tulis banyak kali? Dah buat ice table, dah ada elok-elok semua by column, use the column. Okay, so when you have the molar concentration, macam biasa tak ada jawapan, we are going to have the answer already. When you have the answer already, I believe you proceed to your next question. B is to calculate the Kc. Betul? And I think the biggest problem in your B over here is your Kc value require power yang besar-besar. Kita ada starting off with the product is your NO2 to the power of 4. And then you have your oxygen to the power of 3. And then you have your N2O to the power of 2. Kc, 1 markah. Saya dah biasa. Kc, dapat markah. Kena tulis dengan betul. Okay, so that is your 1 mark already. You have your power 4, kuasa 3, kuasa 2. Masalah dunia. Tekan calculator. Betul. Betul. Okay, pandai guna benda ni. Alright, bracket sayang. Bracket. Okay. Alright, dan value yang kamu kira akan dapat value kecil-kecil, betul? Okay, so bila kamu dapat value yang kecil-kecil sangat ke apa semua, make sure kamu tekan calculator kamu betul-betul lah. Okay, so press your calculator, and as always, tak ada jawapan untuk kamu, kira sendiri. And I have another question for you. I want KP value. I want KP value. If your KP calculated is correct, then your KC is correct. I want KP value. Dah? Kalau siapa yang dah ada KC, KP dia laju je lah. First question, delta N sama dengan berapa? Diana? Hang on, Diana. Diana? Fazini?
-1.
Delta N equals to -1. Ana, sama dengan jawapan kamu? Okay, delta N is -1 over here. So I want KP value. Syuhada?
1.8977.
1.8977. Setuju? Okay, semua setuju? Alright. Semua setuju, saya tak tekan lah. Kalau ada yang tak setuju, saya tekan lah. KP value calculated 1. Lupa. 1 point apa?
1.8977.
1.8977. Kawan kamu dapat KP value is 1.8977. Kalau KC value, kalau KP value kamu betul, that means your KC value and the rest of the concentration yang kamu kira tadi betul lah. Okay, saya tak nak bagi jawapan sebab kalau kawan kamu tak buat, dia tak tekan dah calculator tu. Okay, so sila tekan calculator tu. Okay, next question and also the last question. What happened to the KP value? KP value. What happened to the KP value if the temperature dropped to 0 degrees Celsius? Dah? Berfikir dah? Okay. Mimi, what happened to the KP value if the temperature right now at 0 degrees Celsius?
Decrease.
KP decrease. Betul? Okay. KP directly proportional with temperature. We talked about that many times yesterday. And soalan takkan minta explain. Soalan tak boleh minta explain sebab kamu tak belajar derive. Kalau zaman saya dulu, kita belajar macam mana nak dapat formula tu. So soalan boleh minta explain because you need to know where the formula come from. Kat sini kamu hanya perlu tahu relationship sahaja. Okay, so dia tak akan minta explain. No worries. Okay. Alright. 14. Okay, 15. Soalan ni tak ada equation saya bagi. It's the reaction between hydrogen plus I2 forming Hi. 2 more. Yes. Okay. Saya nak bincang soalan ni. Buat tak? Guna quadratic. Betul? Soalan ni tak ada apa. Soalan ni isu paling besar nak selesaikan quadratic kamu. Yang kuasa 2 tu. How long you spend? Half an hour? Guys, you only have 3 minutes for one question in your objective. You only have 3 minutes. Including reading question, including buka pencil box nak ambil pen, including tekan calculator, including tengah-tengah tu nak pergi toilet, including want to drink water or whatsoever. So drink faster way. Or you bring the marathon bag. I'm just joking lah, antara yang suka minum air dia lah, yang lain tu duduk tenteram macam tak payah. Forever hydrated. Okay. Yes, you only have 2 minutes. 3 minutes, okay, for everything. Quick one. Soalan senang je. Saya nak tengok X yang kamu kira tu. Saya nak bincang X tu je. So all the mixture over here is initial. So soalan senang sebab dia dah bagi initial everything is already in concentration. Bukan number of mole, bukan benda pelik-pelik. Soalan ni like I say, paling-paling susah adalah nak selesaikan quadratic kamu. So that is the initial of your hydrogen. Kenapalah banyak sangat kosong? Kenapa tak bagi darab 10 kuasa negatif 3 je? Apa benda soalan ni? Soalan saya lah kan? Punyalah nak bagi hampa buat salah. Okay. Oh wow, we go with the flow. So the product right now is not zero. The product stated with a certain initial. So we started off with the reaction. Dalam beaker tu kita masukkan hydrogen, kita masukkan iodine. Pada masa yang sama saya masukkan juga HI. So dalam beaker saya bermula dengan kehadiran tiga-tiga orang ni. Okay. So my I stable started with the equation that I give to you. So the balance equation of HI quite simple over there. Hydrogen gas reacting with my iodine, forming your 2 mole of HI gas. And quite obvious, I guess, everybody will be quite happy to do the I stable in concentration. No argument, I guess. So I stable in concentration, masukkan value yang banyak gila kosong saya bagi tu. Ya, yeah, untuk supaya kamu salah salin kosong tu. Oh lah, panggil aku takut sangat Alright, there you go, the initial concentration. And change over here, a quick question to, we try it once again. Diana? Sayang? Oh, panggil sayang pun tak jawab, dia tak jawab dah tu. Hari ni, siapa yang cakap tak sihat tadi? Tak apa? Natasha? Yeah. Can I have the change?
Negative X, negative X, positive 2X.
Perfect. Senang kan? Senang dengan syarat satu. Equation kamu balance dan betul. Okay? Everything depends on the equation. Imagine you started off with the wrong equation. You're gone. Okay? Equation kena bagi betul. So, equilibrium over here. This is the $1 million question. So, equilibrium pun tak ada apa. Tolak X. You have your 0.00414 minus X. You have your 0.0224 plus 2X. Okay? Betul? Setakat ni? Kc given. Kc given is 54.3. The biggest problem arise in today's question is kita bukan nak cari Kc. Kc telah diberi. Apa yang kita nak cari adalah X tersebut. By using the Kc and so on. So the formula of Kc equals to your product Hi to the power of 2 square over your hydrogen gas to the power of 1, iodine to the power of 1. Agree? Okay, welcome to quadratic. The hate and love relationship that you have. So your Hi over here 0.0224 tambah 2x kuasa 2 over with your hydrogen 0.00623 minus x darab dengan 0.00414 minus x. Okay. Can you solve the quadratic? I know some calculator can use it. Belajar cara yang calculator tu. Pergi kat Google, pergi kat YouTube, type how to solve quadratic in your model of your calculator, please type. There is a way how to insert that. Okay? Or if you are very good in maths, you can solve it. You can buka kurungan, tutup kurungan, kuasa 2, whatsoever, solve it. Okay? Done. Ada siapa-siapa dapat ke? Anyone getting the X? Can I have the X? Anyone yang dapat?
1.56599 darab 10 negatif 3.
Satu je, Aina?
Ada 2, Miss.
Ada 2, betul kan? Satu lagi saya?
0.01141.
Perfect. Okay, kenapa saya suruh belajar cara matematik yang calculator pergi tekan tu? If you're having a different model of calculator, I think the way that you insert will be slightly different. Okay, go and figure that out. And if you're not, you just work it out as always. Solve the quadratic, you will get your x. And I think the biggest problem that you obtain over here is the x value ada dua. Yang ni yang kita nak bincang. So, I think Aiman dengan Safan duduk sekali. They say, both of them say x ada dua. So, salah satu yang kawan kamu bagi adalah 0.01141. Aina bagi 1.5649. Panjang sangat tadi. So, saya round off jadi 10 kuasa negatif 3. I have 2x value. But everyone in the ice table is holding an x. And therefore, your x should be only one single value. Betul? Kalau x value yang kamu dapat adalah satu positif, satu negatif, dan life is easy. Kita ambil yang positif. Okay? Sebab tu saya bincang soalan ni. Kalau soalan positif, negatif senang. Tak payah tengok yang negatif, ambil yang positif. Habis. Betul? Alright, when you do quadratic, sometimes you have positive, negative. So we ignore the negative, we take the positive. But what happens when both of the value is positive? You need to look at the initial and the change. Bear that in mind, the x is actually dropped on your change. Most of the time, your x is actually here. Betul? Knowing that your x is actually a change, bear that in mind. Remember your degree of dissociation yesterday? Can you use more than what you have? No. We cannot use more than what we have. When we cannot use more than what we have, how do I choose the x value? Will depends on my initial and my change. Dan my advice, ada dua cara. Tak payah, bila kamu ada lebih daripada satu reactant, tak payah check dua-dua, check seorang je. Sama ada check reactant yang initial paling kecil. Okay, sama ada check yang tu. Ataupun check changes dia yang X darab paling banyak. Tolak 3X, tolak 4X, check yang tu. Dan ataupun conclusion dia seorang satu je. Check seorang je. Tak payah gatal check dua orang. Okay? Alright, I will always choose this one. I will always ask my student to choose this one. Preferable, tengok initial siapa paling kecil. When you have more than one reactant, compare the reactant that have the smallest initial. That is the easiest. Decide who is the smallest initial. I have my iodine as my smallest initial. Kalau iodine yang saya ada hanya bermula dengan 0.004 lebih. Saya ada 0.004. Tapi X pertama adalah 0.01. Logik tak yang berubah tu jauh lagi tinggi berbanding yang saya ada? Tak logik, betul? Alright, so your X1 is not acceptable. Jangan potong X tersebut. Jangan pangkal, jangan panggil apa? Jangan correction tape, semua jangan. Just letak je kat tepi, ignore. Sayang, dia adalah matematik, dua-dua jawapan tu kena ada as a mathematic, betul? So jangan potong, dia kena ada. Tapi kita tak guna. We ignore that value and we take the value that Aina said just now. Jawapan Aina tak salah. Tapi X ada dua value and you need to know how to choose. And the best way to choose is to find the lowest initial of your reactant, compare with the change. Itu je cara dia. So you right now get the X is 1.5649 times 10 to the power of negative 3. This is the X that we will use. Easy, easy. Substitute your X into your ice table. Okay, ada masalah nak substitute your X? Boleh ya? If I don't want to waste my time waiting for you to press your calculator. Saya nak ajar cara je. Okay, saya nak ajar cara je. Okay, kalau kamu perasan at the end of the ice table, semua soalan ice table at the end adalah sama. Jumpa X, masuk balik, dapat concentration. Betul? Okay, semua adalah sama. So, no point waiting for that. Alright, ada masalah? Boleh? Okay, siapa yang nak tulis balik? Siapa yang nak tulis balik boleh. Kalau rasa ice table kamu terlalu compact, tak ada tempat kamu nak tulis balik, boleh. Tapi make sure kamu tulis balik dan label dia adalah siapa punya. If you decided to rewrite your calculation, make sure you show who are you calculating for. Okay, make sure you show that. And well, third world problem. Tekan calculator betul-betul. Okay. How can I do that not to press wrong? What can I do? What can I do? Alright, solve it. Okay, tak ada isu soalan ni. Ada masalah dengan pilihan X? Ada masalah dengan quadratic? How long you spent yesterday night to do this question?
20 minit.
Miss,
20
Yes.
minit.
kalau saya tekan kalkulator kan tak dapat yang 0.01141 tu.
Akan dapat sayang.
Dah try. Sebab
Cuba
dapat
tekan
satu.
balik nanti. Nanti try balik lepas kelas. Biasanya X akan dapat at least 2 value. Kalau value yang sama adalah positif atau negatif. Okay? That is how your quadratic kuasa 2 works. Betul. Your X akan jadi ada 2 unknown. Okay, try. Okay. Lagi soalan? Alright. Okay, kita doakan supaya quadratic tak keluar. Tapi quadratic kita akan jumpa balik di chapter 7 dengan banyak. Ice table semua ni, kita akan jumpa balik di chapter 7 but slightly different. Same concept. Slightly different, talking about acid and base. Okay? Tak apa yang tu nanti. Alright, 16 to 20. 16, 17, 18, 9 ada yang tak boleh buat?
17, Miss.
17.
Degree of dissociation, SO2 tak ada apa, 0.0, ice table sahaja. Okay, yang ni tak ada apa, 17. I love this question. Senang je weh. Alright, this one require a bit of your topic 1. Okay, and I guess yang paling masalah besar dalam soalan ni, benda yang soalan tanya adalah solid. Betul? Okay, so yang itulah masalah dia. So let's see, I started off the question with ammonium hydrogen sulfide decompose. So it's a breaking. The Kp given is 0.11. So Kp given is 0.11. Soalan tanya pasal partial pressure. So we will be using a lot of pressure and we will only taking count of your gas. Betul? Pacik ni boleh bangka siap-siap. Kita tak guna sebab dia solid. Agree? Okay. So 55.0 gram of solid ammonium hydrogen sulfate is placed in a sealed container. So this is, in the other words, mass initial. So I started off the mass initial with mass initial siapa? Ammonium hydrogen sulfate 55 gram. That is my question. Selesai? Okay. So how can I find the partial pressure of ammonia and hydrogen, H2S, hydrogen sulfate? How can I find that? Perlu guna ice table?
Yes.
Yes, no, no, yes. Okay, kita akan buat ice table and look at my ice table compared to yours. The first one, ice table require the balance equation yang soalan dah bagi, including the solid yang kita tak nak guna tu. So, solid kita tak nak guna, let's see what happened to my ice table later on. And then, since everything is given in, pressure Kp, question asking for pressure, and therefore, we will do the ice table in pressure. Tak payah tukar kepada number of mole. Okay? Therefore, my ice table will be in pressure. But we know that if my ice table is in pressure, initial pressure change, pressure equilibrium, my solid will be ignored. Betul? Sayang, bila Miss Wong kata ignore, I didn't mean zero. I hope you realize that zero represent a value. Zero is actually a value. It's not zero. Zero bermakna dia tak ada tapi dia boleh ada. Kat sini dia solid sayang. Dia tak boleh wujud langsung. Therefore, dash. Jangan letak kosong. Faham? And then starting off with the reaction. Okay, where your product over here soalan tak bagi tahu dia berapa. Therefore, we will assume there is no product form straight away. When there is no product form, since they are product, therefore you have a plus X. So you form your final equilibrium partial pressure will be your X. Agree? Okay. Then you should be able to see how your Kp look like. Your Kp will be the partial pressure of ammonia Darab dengan partial pressure of H2S. And as we agree yesterday, we talk about Kp, Kc, Kp, Kp a lot, where the value that you put in must be the value at equilibrium. So let's look at the value at equilibrium. The value at equilibrium right now is this. X. Dan kenapa boleh substitute X terus? Kp given 0.11, pacik ni X, pacik ni X. Can you see that? Nampak dah? Okay. So you will be able to get the X value over here, Iman.
.3317.
0.3317. Kelas 7? 0.3317. Okay. Agree kelas? Setakat ni. Soalan pertama, you are pretty much done. I say pretty much because that is not your final answer. Question asking for the partial pressure, bukan X. Therefore, make sure kamu label balik. Over here, X equals to 0.3317. 0.3317. Okay. Boleh. Bila Kp tak bagi unit ataupun Kp tak ada unit, pressure tak ada unit, kita akan assume terus unit dia adalah ATM. Kalau dia bagi torr atau millimeter mercury or whatsoever, dan dia patut ada unit lah. Okay, pada Kp tersebut. Bila dia tak bagi, dan kita akan assume terus partial pressure dia ATM. Soalan A, settle. Problem arise adalah soalan B. Soalan B adalah start di mana kamu stuck, saya rasa. Soalan tanya mass, tapi mass dalam ice table tak boleh guna. Betul? Mass tak boleh guna because everything that we have on hand right now on the question is pressure. It's about gas. So how can I relate the gas to my solid? One thing, mole ratio. Kita tak boleh guna pressure untuk compare, tapi kita boleh guna mole ratio. Masa kita belajar topic 1, remember we learn about mole ratio, limiting reactance, semua-semua tu kan? Do we ever bother the phase is what? No. Because we use number of mole. Betul? And the only thing I tell you, whenever you're doing mole ratio, the only thing that you can compare is number of mole, because number of mole will remain unchanged. Mass akan ubah, volume akan ubah, tapi number of mole akan kekal. Right? Same thing. You need to do the comparison. You can do the mole ratio comparison, but when you do the mole ratio comparison, you must change your pressure into number of mole. Dan saya nak reactant. Saya ada 2 produk. Pilih, kalau biasa kita pilih yang nombor kecil lah, ratio yang kecil. Tapi kat sini dua-dua 1:1 ratio. Pilih satu je lah, tak payah buat untuk dua-dua orang. So let's say we are comparing your ammonia to your ammonium hydrogen sulfate. So we are going to change this partial pressure, okay, to number of mole. How can I change the partial pressure to number of mole?
PV equals to nRT.
PV equals to nRT, guys. You have volume, you have temperature, but in degrees Celsius, you have pressure. PV nRT. N yang kita nak. Pressure ada, volume ada, temperature ada, R is a constant. Betul? Okay. So there you comes your PV equals to nRT. So PV equals to nRT, but it's the partial pressure of ammonia. So volume equals to the number of mole of ammonia that we are looking for, RT. Be very careful with the unit conversion. Your temperature right now is 250 degrees Celsius. Can I have the Kelvin? Mau tak tanya soalan ni? Haifa masuk kelas tak? Tak apa, jangan buka mic tadi please.
523.15.
Zul say 523.15 Kelvin, and yes, is correct. Volume over here 5 liter. Use your PV equals to nRT, masukkan pressure 0.3317. Volume over here is 5 liter. Number of mole is the one that we are looking for. Therefore, R value guna yang mana Izzati? Anis Izzati, I mean.
Sorry, Miss.
R value guna yang mana sayang?
0.08206.
0.08206 sebab saya dah bagi tahu partial pressure assume ATM. So you get the number of mole of your ammonia, right? Is that what we want? Not yet, not yet, far to go. Okay, next, when you have the number of mole of your ammonia already, as always, we are doing mole ratio. So from equation, you will have 1 mole of your ammonium hydrogen sulfate will react to form 1 mole of ammonia. Okay, it's a 1-to-1 ratio, betul? So tak payah tekan kalkulator pun dapat lah. Soalan saya kat sini satu je. The number of mole of ammonium hydrogen sulfate that you calculate over here is the number of mole initial, reacted, or leftover. The number of mole of ammonium hydrogen sulfate that you compare with ammonia.
All.
Sorry, Iman?
All, because number of mole is constant for solid.
Because number of mole is constant, number of mole is not constant. Concentration is constant. Alright. My question is, saya bagi value terus. I think the number of mole is 0.0386, betul? So due to the 1-to-1 mole ratio, so the number of mole of ammonium hydrogen sulfate that you obtain also equals to this. I repeat my question, man. All right. This number of mole is the number of mole initial, reacted or used, or leftover. Yang diberi, yang kita ada dari awal, atau yang digunakan, yang telah digunakan, atau yang tinggal.
Reacted.
Leftover. Haris kata leftover, Nawesh kata reacted 1-to-1. Mai, lawan. Tengok siapa menang hari ni. Lagi? Ni tak ada pemenang lagi. Nawesh say reacted. I think. Haris say leftover. Orang lain? Ghost?
Yang tinggal.
Iman say yang tinggal. 2-to-1 Nawesh. Faster cari gang. Iman say leftover, yang tinggal. Come on, lagi. Fikir. Go.
Leftover.
Leftover. Balkis?
Reacted.
Balkis say reacted 3-to-1. Go say leftover tadi. So Balkis join gang Nawesh. 3-to-1. 3-to-2. Lagi orang lain? Mimi?
Reacted.
Reacted 3-to-3. Nabil?
Reacted.
Reacted 4-to-3. Azri?
Tak pasti je.
Tak pasti, tak ada pilihan ni. Alright, undi anda gagal. Kita ada 2 orang yang duduk sekali, Aiman dan Safan. Which one is your answer?
We think is leftover.
Leftover. Okay. I think it's not leftover. Sayang, tengok. You compare with your product. Okay, fikir logik. Produk terhasil sebab reactant digunakan atau sebab reactant tinggal? Kamu nak hasilkan produk, betul? Means kamu akan gunakan reactant banyak mana untuk hasilkan produk. Agree? Right? How much I have used to produce my product. That is the logic dari reactant ke produk. So bila kamu terbalik daripada produk kepada reactant sayang. When you go terbalik, produk akan menentukan balik reactant banyak mana yang telah digunakan. The number of mole that you calculate over here is the number of mole reacted. How much has been used? Okay. Boleh. And if you read the question carefully, if I'm not mistaken, the question having the word mass of ammonium hydrogen sulfate at equilibrium. So another problem over here. Equilibrium is not in the list. Tadi saya bagi initial, reacted, leftover. So equilibrium over here means which stage? Equilibrium over here means dia adalah stage apa yang kita nak. Adakah kita nak dia reacted? Ataupun kita sebenarnya nak dia duduk kat leftover yang final lah. Which one? Come on. Not sure? Initial is apa yang diberi, given. Change over here obviously is your reactant. So equilibrium over here is actually your final. Your leftover. Okay? Alright. Therefore, yang kamu cari adalah yang reactant. Banyak mana yang saya guna untuk hasilkan amonia. Tapi yang saya nak bukan banyak mana yang saya guna. Yang saya nak adalah number of mole ataupun yang saya nak adalah mass of ammonium hydrogen sulfate that left after the reaction. So, we started off with the mass initial, if you remember. We started off with the mass initial 55 gram. Can I find the mass of ammonium hydrogen sulfate left over? Okay. You need a molar mass and be careful because you're having your sulfur over there. Sulfur 1 decimal place, 32.1. Saya nak mass left over. Dah? So you definitely need the molar mass. From the molar mass, then you will be able to calculate the mass, blah, 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 blah. Mass reacted first. Then you can calculate the mass left over ataupun mass at equilibrium. The molar mass calculated, by the way. Alah.
51.1.
1.1.
50.
1.1.
51.1. Thank you. Baru nak kira, tak dan. 51.1. So the mass? (1.9879 gram per mole. Betul? Can I have the mass left? Senang je kan? 53.0121. Correct? So, bukan masalah. Masalah dia bukan kat bawah ni. Masalah adalah kat atas ni yang kamu kira, kamu kena tahu number of mole yang kamu kira ni, adakah dia jawapan akhir yang kita nak? Dia adalah number of mole apa. And always remember, when you are comparing your reactant with the product, the number of mole that you calculated must be the number of mole used. Banyak mana kamu guna, baru boleh hasilkan banyak mana produk. Always remember that. Sayang, topik 1 kita belajar hari tu. Bye-bye, gone case. Gone case. Remember your limiting reactant, we have mass of excess reactant. Ya, mengangguk sekarang duk mengangguk. Tadi saya duk tanya duk apa leftover. Kick you. Alright, you have that. The next question asking for degree of dissociation. And if we read the question again, like I promised yesterday, like I said yesterday, if the question asking for degree of dissociation, dia takkan bagi tahu siapa punya. Perasan? Because like we say yesterday, degree of dissociation boleh kira untuk siapa sahaja.
Reactant.
Reactant. Thank you. Degree of dissociation, we can only calculate for our reactant. And for today, our degree of dissociation adalah for ataupun of your reactant NH4HS. And if you remember, the degree of dissociation formula dia adalah change over initial. Dan saya bagi tahu the change and initial can be in mole, can be in concentration, can be in pressure, can be in mass. Betul? Kan banyak mana kamu berubah, banyak itulah kamu bahagi. So your change adalah banyak mana yang kamu guna. The change is definitely the reactant. Banyak mana yang kamu guna, itulah perubahan dia. So the reactant is 1.9879, the initial 55 degree of dissociation. Mesti besar gila, mesti kecil gila tak pegaban. Daripada 55 gram baru guna 1.98 gram. Sikit gila. Excess, mampus. Excess gila-gila. Okay.
Miss,
Yes.
bukan yang mass reacted tu 1.9725 ke?
Ya, saya salah. Apa tadi tak cakap?
Takut.
Takut. 1.9725. Ya, saya salah tekan kot. 1.9725. 1725. So kat sini pun 1.9725. 55 minus 1.9725. Yeah. Okay. Alright. Takut. Bila tak buat kerja tu tak takut kau? Alright, agree? Happy with that? Ada lagi soalan yang tak boleh buat? Saya rasa soalan yang belakang-belakang tu bukan tak boleh buat. Soalan belakang-belakang tu adalah bermula soalan quadratic nightmare kamu. Okay? Soalan belakang tu soalan dia tak susah. Ice table dia guna quadratic. Okay? So, saya rasa saya tak nak bincang kot. As in, saya tak nak bincang sebab saya tak nak tunggu kamu tekan X tu. Okay? Cuba buat soalan ni. Soalan 20 adalah soalan yang kamu kena submit kat Google Classroom nanti. Okay? Sebab dia ada semua benda yang saya nak tengok. The KC-KP relationship, your ice table, your sketch, curve and everything. Okay? Ni soalan ni memang saya tak bincang lah. Kelas mana pun saya tak bincang. And yang lain saya rasa satu je. Quadratic. So think very carefully X mana yang kamu nak guna. If you have 2X value, X mana yang logik yang kamu boleh guna. Dan kalau X yang kamu kira satu positif, satu negatif, negatif adalah definitely ignore quotient. Kita mesti ambil yang positif. Kita tak boleh ada perubahan yang negatif. Kalau perubahan yang negatif bermakna dia ubah ke dia tak ubah sayang? Betul? Alright, mana boleh hang ada duit yang negatif? Hang tu tak ada duit tu Okay? Alright. So that is quite simple. And the last 30 minutes, I think I want to go for Q. Is that okay? All right. I think I have covered most of the thing that I want to cover for your topic 6 about calculation. Okay, and they are not tough. The concept is simple. Concept dia satu. Saya nak cerita ice table dengan equilibrium. Saya nak ajar pun saya memang malas. Konsep dia tak ada apa. Saya nak benda tu seimbang. Saya nak benda tu adalah initial atau equilibrium. That's it. Alright? So dia tak ada isu besar-besar lah pasal konsep tu. Tapi calculation tu penting. Okay, and we can see the concept in the calculation straight away. So I hope you have jotted down a bit of all the extra things that I given to you throughout all the questions that we discussed. So the biggest problem, the last problem, not biggest, smallest problem ever, and one of the things I love the most. Paling senang, soalan pun paling senang nak detect. Sama ada kamu kena kira Q atau kamu tak perlu kira Q. Benda yang paling penting dalam Q and K, I want to show you is the formula is the same. Agree? Product of the coefficient versus the reactant of the to the power of coefficient. So first and foremost, you need to know that your Q and your K sharing the same expression. Yang tu tak ada apa. Dengan kata lain, the formula is no longer an issue right now. Sebab formula kalau kamu boleh tulis untuk K, kamu boleh tulis untuk Q. Okay. The second thing that I want to insist so much, and every year there will be student doing this mistake, is bila saya kata Q compare dengan K, that is the general, ladies and gentlemen. When I compare, your QP must be with KP. Your QC must be with KC. When I say you can compare your Q and K, they must be in the same term lah. How can you compare something is not in the same term? Alright? Yang ni adalah the biggest problem every year. One of the biggest problem. Okay? The second thing, if they are, the third thing, and also the last thing, okay? Since the formula is the same, so what makes them different? What makes the value that you put into the Q and the K is different? K is your equilibrium constant, as we all know. And as we all agree from yesterday, from last week in your tutorial, in your lab class, all this discuss about one thing, equilibrium. Betul? Alright, all this discuss about equilibrium. Semua value yang kamu letak kat situ mesti adalah concentration equilibrium or pressure equilibrium. Betul? Okay. But how about your Q? Even though the formula is the same, alright, even though the formula is the same, but what makes it different is the value that you put into your Q. Okay, the value that you put into the Q is a value that you don't know. You're unsure whether they are at equilibrium or they are not at equilibrium. They can be at equilibrium, they can be before equilibrium, or they can even be after equilibrium. Yang pasti, you don't know where they are right now. Okay, yang pasti, you don't know whether it's at equilibrium or not. And you know that it's not initial. Dia bukan initial, tapi saya tak tahu dia equilibrium ke tak. That is the time you use your Q. And why I say, soalan senang, because in the Q question, all right, in the Q question, you will always have this. Okay, this sentence. Which guesses were? Set. Dia sentiasa ada ayat ni, selalunya. Soalan bila tanya, is the system at equilibrium? Alright, decide whether the system at equilibrium. Okay, is the reaction at equilibrium? Antara soalan dia. Habis dah, okay. Sebab tu saya cakap dia adalah antara soalan yang senang. Bila soalan kamu tanya, based on the blah 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 above, is the system at equilibrium? Are we achieving equilibrium? Are we exceeding equilibrium? The moment dia tanya soalan macam ni, sayang, Q masuk. Okay? And why question 21 also Q, lain sikit sebab dia tanya which gas will increase in concentration and which will decrease in concentration when the mixture comes to equilibrium. When the mixture comes to equilibrium means at this moment, the mixture is not equilibrium. Make sense? Okay, the system is not at equilibrium, so what will happen when it comes to equilibrium? So, bila kamu baca ayat dan ayat-ayat soalan tu bagi tahu benda ni sekarang bukan pada equilibrium. That is the time you know your Q come in. Okay? And we have 3 conditions. Just a bit of conclusion over here. Can I have your conclusion from you? If my Q equals to K, what it means?
At equilibrium.
At equilibrium. If the Q equals to K is already at equilibrium, do I need to shift to anywhere? Sayang, bila kita dah kata Q yang kamu kira sama dengan K, K tu equilibrium, dah sama, at equilibrium. Duduk diam-diam tak payah buat apa. Because we want to achieve only one thing. We want to do one thing, we want to achieve equilibrium. Okay? Q less than K. Obviously not at equilibrium. Tak sampai. Soalan saya, dah bagi jawapan. Tak sampai atau dah lebih? Tak sampai. Jawapan dia adalah tak sampai. Okay, not at equilibrium and is haven't reached equilibrium. Kenapa haven't reached? Kenapa saya kata tak sampai? When Q is equals to your product of the coefficient, reactant of the coefficient, and sekarang Q kamu kecil sayang. Betul? Dan saya ada teknik a bit lah untuk ajar. Bukan teknik apa. Sebab saya tak nak, benda ni kamu tak boleh imagine. Kamu tak nampak pun equilibrium position tu. Betul? Kamu bukan nampak pun sistem kamu bergerak dari reactant kepada produk atau produk bergerak kat reactant. Kita tak nampak benda tu bergerak, berenang dalam beaker kamu. So to avoid your imagination problem, alright, everybody knows you are not that creative, so we skip that. But you're very creative when doing the TikTok video and whatsoever things. But when we ask you to imagine, imagine sikit molecule tu ada. Tak nampak Miss Wong. Why? Because the molecule is not in TikTok. I need to teach in TikTok. Then you'll be very, very good, I believe. So, a bit of things to solve your imagination issue is, kita guna matematik. And to make your life even easier, tak payah compare dengan reactant. Compare terus dengan produk. Sebab directly. Betul? Dua-dua duduk atas. So when your Q is less than your K, that means your product is less. Q kecil, produk kecil. Dan bila bahasa dia produk kecil, that means product is not enough yet. Betul? Reaction dah bermula. Alright? Reaction dah bermula. Tapi produk tak cukup lagi. Bila produk tak cukup lagi, bermakna you haven't reached equilibrium. Nampak? Okay, and I have a reaction that always everybody know I have reactant on the left and then I have product on the right. Dan sayang, product tak cukup. You're not having enough product yet. So in the other words, we need more product. Betul? So when you need more product, I will be going to the product or I will be going away from the product. Kita akan menghala ke produk atau kita akan bergerak dari produk.
Menghala ke produk.
We will be going towards product. Sebab bila kita menghala kepada dia, bermakna kita akan hasilkan produk. We will produce product. Okay. Kenapa nak produce produk? Sebab produk saya tak cukup lagi. Produk saya masih sikit. Okay ke? So, if the Q is less than K, then your reaction will shift from left to right. Bila Q lebih kecil daripada K, mesti bergerak left to right. Mesti. Sebab produk saya tak cukup, so saya kena hasilkan lagi banyak produk. Make sense? Okay. And dah belajar Lee Chatterley kan dalam amali? Dalam Lee Chatterley principle, kita guna perkataan equilibrium position shift. Betul? Alright. Kat sini kita tak boleh guna perkataan equilibrium position. Mesti guna perkataan reaction sebab your system haven't reached equilibrium. Kita tak ada lagi equilibrium position. See the difference? Alright. We don't have the equilibrium position yet because we are not achieving equilibrium yet. Tak sampai lagi sayang. Okay, so reaction will shift, not equilibrium position. Make sense? Okay. So, vice versa, and also the last thing, when your Q bigger than the K. Sama lah. Alright, when the Q bigger than the K, sama. You have your Q bigger than your K. That means your Q equals to product coefficient over reactant coefficient. So, sekarang Q kamu besar. So, bila Q kamu besar, produk kamu tinggi. Produk tinggi bermakna extra product. Alright, extra product means you have terlebih. Produk dah lebih sangat. So bila produk dah lebih sangat, that means it's already exceed the equilibrium. Dia dah lebih daripada equilibrium. Dia dah lebih daripada sepatutnya yang kamu ada. Okay, it's more than what you should have. Therefore, you have your reactant macam biasa. You have your product macam biasa. And then your product sangat banyak. So bila produk kamu dah terlebih banyak, produk kamu dah lebih daripada apa yang saya patut ada. So we will be shifting from the product to the reactant. Kita akan gunakan produk tu. Alright, kita akan gunakan produk tu. Alright, we will use the product so that we reduce the product that you have. Okay, kita nak kurangkan balik dan lebih sangat. Too much. So kita nak guna balik, kita hasilkan balik reactant. So it will forever shift from right to the left. And bear that in mind, over here, the one that will be shifting is your reaction, bukan equilibrium position. Okay, yes. Thank you. Sure. Okay, question? Alright. So, ada soalan yang tak boleh buat? 4 soalan ni ada yang tak boleh buat? Ada soalan yang tak boleh buat? Can I have your 21? Can I know the Q is bigger or larger than K? For 21? Bigger or larger than K? Anyone? Tak cakap, kita tunggu.
Bigger.
Bigger. Your Q is bigger than your K. 21. Ang kira tak? Kau hang tembak je. KC is given. KC given is 1.2. Soalan dah bagi, KC is 1.2. Starting with hydrogen, 0.6. So hydrogen, dia bukan initial, bukan equilibrium. So Miss Wong tak label apa ya. Kita tak tahu dia sekarang dalam keadaan apa. Do not put anything. And then you have your nitrogen, 0.6 molar. You have your ammonia. Over here, 0.48 molar. Which gas will increase and decrease? Blah, blah, blah. Kita kena kira Q dulu lah. So my Q over here, QC equals to my ammonia square over nitrogen hydrogen cube. Betul? Saya dapat lebih kecil. Kamu dapat lagi besar ke? Saya salah kira ke? Everybody getting bigger than? No? Lau say no? Ada anybody supporting Lau? Smaller. Your Q kat sini kira sendiri, tapi your QC will be smaller than your KC. Betul? So, benda yang kamu kena jawab dalam nota, guna je yang nota, guna je apa yang dalam video tu. System not at equilibrium. Alright? So, bila benda ni not at equilibrium, saya tak pernah nak hafal Q tu. Kalau Q nak bergerak ke mana, saya susah nak hafal. Saya sangat susah nak hafal. Saya hafal macam ni je. Q kecil, so produk sikit. Bila produk sikit, produk tak cukup. Alright, produk sikit means tak cukup. Bila tak cukup, saya kena hasilkan dia lah. That's why I shift from the left to the right. Betul? Okay, I will straight away go. Reaction. Shift from left to right. Agree? Okay. So, bila from left to right, bila equation kamu bergerak daripada kiri ke kanan. By the way, tahu ke kiri kanan maksud saya adalah sebelum dan selepas arrow? Kalau tempat yang kamu bergerak dari, if you are moving from, concentration dia mesti kena turun. Sebab kamu gunakan dia. Kalau arrow bergerak kepada orang tu, you are moving to. Alright, you are moving to that place, the concentration over here must increase. Because you produce them. Nampak? Alright, the arrow going there and the arrow moving from and to. Therefore, over here, concentration and to over here will decrease. Concentration H2 will decrease, but concentration ammonia will increase. Nampak? Okay ke? Always remember, kawasan yang kamu menuju tu, when you're moving to that direction, the direction that you're moving to means the concentration increase. Kamu bergerak ke dia, kamu hasilkan dia. Okay? So, another hujung tu, another side tu, vice versa. Right? When you're moving to that side, when you're moving to this side, that means you're going to produce this side. Okay? And pembahagi dia of the side, siapa kiri, siapa kanan adalah before arrow, after arrow. This arrow. Nampak? Okay. Senang. Saya ingatkan tak nak ajar je ni. Q. QP or QC? QP. Bigger or smaller?
Bigger.
Bigger.
Okay. Alright, kita sendiri. Bigger, betul? QC or QP?
QC.
QC. Bigger or smaller?
Smaller.
Smaller. Okay, yang tak setuju bagi tahu soalan bagi KC. Okay, boleh. This one? Bigger or smaller?
Smaller.
Mesti smaller kot saya rasa. KP dia bagi sampai 60.6. Mesti smaller. Betul? Okay. Question. Senang. What happen if one question? Tak adanya aku nak lepaskan hang macam tu kan. Last question of the day. Senang sangat yang tu. Reaction below nak buat apa Reaction below buat hydrolysis of water. Yes. Last question.
Semua kita cari mula.
Azri siap dah? Go. Smaller or bigger kau?
Bigger.
Bigger. Azri, smaller or bigger?
Bigger.
Kamu still tengah kira, Mimi still menulis. Syuada dan? Dah? Anas pun dah. Good. Alia? Natasha dah? Zul? Novesh done? Zul?
Belum.
Nabil? Haifa baru masuk, Haifa? We give 1 more minute, 2 more minutes to your friend maybe. Habis lah soalan 3 minit, bye-bye dah. Guys, go to the campsite, open up your CamFriend, pergi download CamFriend kamu. Dalam tu ada soalan objektif. Belakang-belakang CamFriend setiap topik tu ada soalan objektif. Okay? And do all the objective. Okay? Do all the objective. And jawapan ada terus ya dalam tu. Siapa yang dah buat, if you realize the option of A, B, C, D in the objective question, dia ada satu je option yang ada dot. Alright, go and open up your CamFriend. If you have done the objective, there is actually answer stated. Okay? And we give you answer, it's not because I want you to have the answer. Guys, you need to work it out why the answer is like that. And if the answer is not the same, kamu dah kira 10 kali, but the answer is still not as what you want, ask. Okay? Sama ada jawapan tu salah ataupun you got something misunderstanding about the question, then you ask. Okay? Try that. Tak banyak, saya rasa satu chapter mungkin ada dalam 30 question, I think. Try. Okay, and for your information, objektif sebelum ni adalah objektif level C1, C2. Bermakna soalan objektif dalam tu adalah soalan objektif senang. Soalan objektif dalam final kamu adalah soalan objektif C3, C4. Okay? So you must be able to understand and able to answer all the question in your CamFriend right now. The objective. Dia terbalik sayang. Dulu kita ada paper 1, paper 2. So paper 1 adalah soalan level C1, C2. Lepas tu masuk kat paper 2 soalan subjektif baru masuk C3, C4. Tapi sebab sekarang kamu tak ada subjektif, so C3, C4 tu kita bawa masuk ke objektif. Okay, so subjektif yang kamu duk buat ni adalah latihan dan latihan yang senang. Okay, this question. What is the trick in this question? Anyone? Only one trick. Kalau saya tak panggil nama pun memang tak nak jawab. Fatin? After 3 months, man. Come on. Fatin?
Yes,
Panggil
Miss.
nama. Yes. What is the trick of this question? Only one. Alright. Soalan bagi number of mole, betul Fatin?
Yes.
So daripada number of mole Fatin kira apa sayang?
Molarity.
Fatin kira concentration. So what are you going to do from all the number of mole, you will be changing to the concentration of H2O. From the number of mole of your oxygen gas, number of mole of your hydrogen gas, semua benda kita tukar kepada concentration. Agree? And from the concentration, all right, what can we find from this concentration? Tengok hang boleh tahan ke aku boleh tahan? Aku tak ada kerja dah. Kita tunggu. Kita tengok kita nak ambil buku apa. Go, shut up. Nawaz, shut up. Anas, shut up. Eng, shut up. Lau, shut up. Azri, shut up. Aiman and Safan, shut up. Kita tunggu yang lain. You have the concentration. You calculate the concentration. And then what do you find?
KC.
Nurin, thank you. You're here. KC. All right. KC, okay. Jauhnya pergi. Okay, tak apa. The question gives to you KP. The biggest trick over here, tak macam soalan tutor kamu. Soalan tutor is very, very straightforward. Dia bagi KC, kamu cari QC. Dia bagi concentration atau number of mole. Dia bagi KP, kamu cari QP. Dia bagi partial pressure. So the trick of the question over here is, soalan tak bagi benda yang kamu cari. The question started with KP. So Nurin kata, I changed this KP to KC. By using the formula of KP equals to KC, oops, besarnya C saya, bracket RT delta N. Next question, delta N. Yang lain, on top of yang lain, nama tadi adalah Nurin. Shut up. Yang lain, delta N. Bila kawan kata delta. Yes, Balkis?
1.
Delta N equals to 1. Kelas 7? Okay. So you have your KC, KP conversion over here. That is the biggest trick. And because of all the concentration, therefore you will be able to calculate your QC. And like I say over here, this will be the type of question that coming out as a Q3. How to make the Q question daripada sini jadi susah sikit. This. Susah sikit je. And the only thing I changed compared this question compared to the 4 question in your tutorial is I did not start with what you calculate. Okay? And by changing that little thing, by changing this little thing, you need to do another extra work. That is what we call Q3, QC question. Di mana jawapan kamu tak dapat direct. You need to do one more thing, you need to do 1 or 2 more steps before you can get your answer. And this will be the thing coming out in your final. If it's come out. That is the level of question. So that's why at the very beginning, just now when I tell you about K and Q, you must compare the respective, the same respective Q and K. Kalau yang kamu cari kat sini adalah QC, you must always compare your QC with the KC. And can I have the value of QC? Yang lain diam macam biasa. Cepat weh nak azan dah.
5.1009.
5.0
1009.
5.1 blah 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 blah. Okay? Can I have the KC? Aiman diam. Anis?
2328.
Betul. Kalau siapa yang compare dengan KP, dia akan dapat lebih besar. That is the trick. Okay. And last thing, Diana, are you there?